I have just replaced the ceramic cartridge on a Dance D215158T bathroom faucet. Fine. Why would I talk about a little bit of common household plumbing here? Here's why. A custom steel and FDM printed plastic socket to finish the job. Welcome to Barrett Works. There was no immediate, easy way to remove this somewhat custom, somewhat frozen in place cartridge retaining nut that some engineer somewhere didn't have the decency to design with flats for a wrench. So I used the Replicator, meaning my collection of CAD, shop, 3D printers, along with a strategic order from McMaster-Carr to create a custom tool. So this was the problem. A relatively thin-walled brass retaining nut with threads on the outside and 4 indentations along the outer edge, or call it 4 crenellations. It's a svelte cousin of a castle nut, and no matching socket from Dan's or anyone else I could find. So I had 2 options. Find and buy an adjustable pin spanner of some sort that would fit, or create a socket myself. You can guess which I'd prefer. I fired up Shaper 3D. I needed to engage the 4 indentations, or at least 2 of them, to transfer the rotational force needed to break this, I thought, thoroughly frozen nut free. I certainly couldn't get it free with my hands, with a small strap wrench, or even with some light tapping with a hammer and a slotted screwdriver in the indentations. Of course I could and would apply heat to the nut or the piece it was threaded into to help break it free when I had something to properly engage with it. I started the design with a round face and a circular channel, I'll call it the socket, to fit snugly over the thin end of this nut, and an open center so the stem of the ceramic cartridge, the actual valve component, wouldn't conflict with the socket. From there, I briefly considered incorporating small surfaces that would engage with the indentations in the nut as part of the print. Easy to design, but if the nut was truly frozen, I suspected I would need something stronger, even if I printed the socket in an engineering filament. I wanted metal on metal to engage with the indentations. I came up with the idea to embed 4 common slotted screwdriver bits into the printed socket, placing them so that each face of the bit was exposed to provide a metal on metal interface with the wrench. At the same time, the tip of the blades were exposed in the socket channel to provide a metal-on-metal interface with the indentations. And this is where McMaster-Carr comes in. Before I explain their role, let me be clear. I have no relationship with them other than as a normal customer. If you look at this slice of the design, note that in order to have the embedded tips of the slotted bits engage with the nut indentations at 90 degrees, so as not to slip or create inward or outward force, and have one face exposed for a parallel metal-on-metal surface for the wrench, the bits had to have their blades perpendicular to 2 of the hexagonal faces. No problem. I did a quick search on Amazon, and there was a pack of them that clearly showed this relationship in the pictures. The bits arrived that evening, and lo and behold, that's not the way they had been made. None of the blades were 90 degrees to any of the hexagonal faces. In fact, this pack of 8 varied one from the other. I packaged them back up for return. So I ordered a different, equally no-name and inexpensive set of bits, again from Amazon, that also showed this relationship in the product pictures. When they arrived the next day, no surprise, though I have to admit I was surprised, there was no ambiguity in the images. They too didn't have this characteristic, though at least they were all the same this time. I don't know why I didn't go to McMaster-Carr first. I had it in mind to do this really cheaply, also to get the bits here even the same day as Amazon can do. In the end, I ended up wasting 2 days and had 2 sets of bits I had to return. Yes, it was cheaper from Amazon than McMaster-Carr, but not that much. And not at all if I count the time I spent poring over a veritable zoo of listings of incomplete, and it turned out inaccurate information. At McMaster-Carr, the order took 10 minutes at most, and that included downloading the highly accurate 3D step file of the bits. If you don't know this, you need to. McMaster-Carr provides downloadable CAD files for, well, all of the hardware I've ever ordered from them, including some slightly complex mechanisms. They may provide CAD for every product they sell. I'm not sure. If you know, chime in the comments and let us know. I had intended to carefully measure the bits that arrived to create a simple model of them to use as a cutting tool in the basic socket shape that was waiting in Shaper 3D. Ordering from McMaster-Carr avoided that design from measurement step completely. And I already knew from past experience that the provided CAD file would be a perfect match for the parts. And, by the way, I happened to be in McMaster-Carr's first UPS delivery zone, being not that far away in the next state, so orders placed by mid-afternoon arrived the next business day anyway. After I placed the order, I dropped the downloaded step file into my design project, scaled it to 102% to relax the custom fit holes that would be cut, pattern copied it around the part so there were 4 of them with their blades aligned 90 degrees to the center line of the channel, and cut them out of the socket with a single command. I also designed the socket to be in 2 parts so that it would be easy to insert the bits after printing rather than trying to press them in during a pause in the middle of the print, and included holes for threaded heat inserts so the second part, the end cap, could be screwed into place, trapping the bits. So the next day the bits arrived and their fit with the already printed part was perfect, though perhaps a bit tight. Tapping them lightly with a hammer drove them all the way into their form-fitting pockets. If I never remove them, perhaps it's the perfect fit. If I were designing this to take them in and out periodically, I'd experiment with 103%. I installed the heat inserts and screwed the end cap on, and I had my test version of the custom socket. As it turns out, the elements of the design I'd created for engaging with the wrench, the center waist, I'll call it, that transitioned to square and exposed the face of the hex bits, was entirely unnecessary. While the cartridge retaining nut was certainly stuck, it turns out it was not frozen. And when I placed the socket on it, and it did engage properly with the indentations, a perfect fit, which was quite satisfying, and I turned it by hand, it came off on my first attempt. I'm almost disappointed. It certainly helped that the socket has a fairly large 50mm diameter. It was easy to turn with a fair amount of force, even without a wrench. All of this occurred with the test part I had printed in Overture PETG, just to confirm the dimensions. The planned second print of a final tool in Prusament polycarbonate blend carbon fiber turned out also to be unnecessary. And the socket? With 6 perimeters and the embedded bits, it's heavy. It feels good in the hand. I wish I had more I needed to do with it. So I'll keep the socket as it is with the bits in place. We have 2 of these faucets, and who knows, the other might need its cartridge replaced at some point. In the meantime, I've learned my lesson. Actually, again, when I can, I should get parts from McMaster-Carr. Life is too short to spend so much time swimming in the sea of crap and no-name brand confusion that is Amazon. McMaster-Carr is more expensive, or appears to be, but it's worth it. And if I figure in the cost of the time and extra work inferior information or parts creates, they might not be more expensive after all. Someday, I'll be able to walk up to the replicator in the wall and say, I need a socket that will engage with the Dan's D215158T cartridge retaining nut, or perhaps instead list out a set of precise dimensions and characteristics, and then the part will simply appear a short while later. We've all seen that in Star Trek. But for now, my replicator, my own 3D design, and 3D printers, and the shop does the job. It's slower, and it takes a bit of skill, but it's working pretty well. Thanks for watching. If you haven't subscribed yet, please do and hit the like button. Catch you next time.